In this video, we're going to talk about topic 1.11, equivalent representations of polynomial and rational functions. This is going to be part 3 of this topic. So in this video, we are going to talk about Pascal's triangle and the binomial theorem. So the first thing this says is that expanding expressions in the form of a plus b to the n power can be tedious. So we're going to start by expanding x plus 3 squared and x plus 3 to the third power. So you should have some blank space on the very last page of your notes where you can write this out if you need more space, or you can grab some notebook paper. So we're going to start by expanding x plus 3 to the second power. So if we were to expand this, remember that exponent tells us how many x plus 3's we have. So we have 2x plus 3's. Now from here, we can multiply this out. I am going to use the FOIL method. So that would be first times first, so x times x, which is x squared, x times 3, which is 3x, and I'm going to go ahead and scoot this down so I have some space. Then I'm going to do 3 times x. That gives me a 3x. And then last but not least, I have 3 times 3, which gives us 9. So from here, I can combine my like terms. I have x squared plus 3x plus 3x is 6x plus 9. So this right here represents the fully expanded binomial. Okay, so I'm going to go back to the notes and I'm going to go ahead and write this out, that this multiplied out into x squared plus 6x plus 9. Now, I'm going to go ahead and go back over here, and now we're going to multiply out x plus 3 to the third power. So that now means we have x plus 3 times x plus 3 times x plus 3. Well, we have already multiplied out 2 of these, so we can go ahead and replace that with what that equals, and that equals x squared plus 6x plus 9. And so now we just need to multiply out x plus 3 with the x squared plus 6x plus 9. So same thing, first times first. So that would be x squared times x. That would be x to the third. Then we have x squared times 3. That would be plus 3x squared. Then we can take 6x and multiply it times x. So that would be plus 6x squared. And then we can take 6x times 3. That would be 18x. Lastly, we have to take the 9 and distribute it. So that would be 9 times x. That would be plus 9x. And last but not least, 9 times 3. That would be a 27. So now we can go ahead and combine our like terms. So we would have x cubed plus 9x squared plus 27x plus 27. And this right here would be the fully expanded. Okay, now what if we were asked to find x plus 3 to the fifth power? Would you really want to have to write this out 5 times and then multiply and just keep multiplying? I don't think so. So the binomial theorem, or Pascal's triangle, is going to help us with this. Okay, so I'm going to go ahead and write this in right here. And so we got x cubed plus 9x squared plus 27x plus 27. Okay, so let's take a look at Pascal's triangle. Before we look at that, I want to see if you can figure out the pattern. So the pattern or the triangle starts like this. It starts with a 1 on top. The next row has a 1 and a 1. The next row has a 1, a 2, and a 1. The next row has a 1, 3, 3, 1. So see if you can think about what the next row is going to be. So when we look at the next row, it would be 1, 4, 6, 4, 1. So take a moment to pause and see how we could get those numbers. So now the next row would be 1, 5, 10, 10, 5, 1. Okay, so if you haven't caught on, the pattern is you take the previous two numbers above and add them. 1 plus 1 gives you 2. For the next row, you have 1 plus 2 gives you 3. 2 plus 1 gives you 3. Then you have 1 plus 3 gives you 4. 3 plus 3 gives you 6. 3 plus 1 gives you 4. You have 1 plus 4 gives you 5. 4 plus 6 gives you 10. 6 plus 4 gives you 10. 4 plus 1 gives you 5. So can you come up with the next row for Pascal's triangle? So we should have 1. Then we do 1 plus 5, which is 6. 5 plus 10, which is 15. 10 plus 10, which is 20. 10 plus 5, which is 15. And 5 plus 1 is 6, and it ends with a 1. So another important thing is that it always starts with a 1, ends with a 1 on every single row. Starts with a 1, ends with a 1. And you can expand this as many times as you need. So why is this important? Well, based on the second number in each of these rows, it tells you about your exponent. So if my exponent is 2, then I want to use the row that has the second number of 2. If my exponent is 3, then I want to use the row that has an exponent of 3. If my exponent is 5, then I want to use the row that has the second number as a 5. So your exponent is going to match the second number in each one of the rows. That's how you know which row to use. Okay, now before I go back to the notes, I do want to show you what it looks like for x plus 3 squared and x plus 3 cubed, and even go through and show you what x plus 3 to the 5th power looks like. Okay, so we already know what x plus 3 squared and x plus 3 cubed answer is. Now I want to show you using Pascal's triangle. So if we're going to go back and we're going to do x plus 3 to the 2nd power, we are going to use the coefficients from the row that has a 2 as the second number. So right here. Now, I like to do this going down vertically. So what I mean by that is I like to write it as 1, 3, 2, 1. And so what we do here is we are going to take the very first thing in the binomial, and you're going to start with that, and you're going to give it an exponent of 2, and it's going to decrease until there's a spot with no x. Okay, so 2, 1, no x. Then you're going to take the second part, which is a positive 3. You do need to make sure you include the sign, and you're going to do the opposite. I like to start at the bottom and do 3 squared, 3 to the first, and then no 3. So notice how this one has an x but no number. This one has both of them. This one has no x and just the number. That's how it will be every time. So the first term, the numbers get smaller. The second term, the numbers get bigger. Okay? Now from here, we just simplify it and multiply it out. So 1 times x squared is x squared. 2 times x times 3 is just 6x. 1 times 3 squared is 9. And so what this tells us is that x plus 3 squared is just x squared plus 6x plus 9. And that is the exact same thing that we got up here. So now if we do x plus 3 to the third power, just so you can see it again, okay, that means now we're going to use the row that has 3's in it. So we're going to use 1, 3, 3, 1. So we have 1, 3, 3, 1. So again, we take the first term, which is x, and we're going to start with the exponent of 3 and work our way down until we have no exponent left. Then you take the second term, which is a positive 3, and you do the opposite, or you work in the opposite order. So I like to start at the bottom and work my way up. But if you want to start with no 3, 3 to the first, 3 to the second, 3 to the third, that's fine. So again, now we just multiply this out. 1 times x to the third is just x to the third. 3 times x squared times 3 is 9x squared. 3 times x times 3 squared, that would be 3 times 9 times x, which would be 27x. 1 times 3 to the third, well, 3 to the third is 27. So this, we get x to the third plus 9x squared plus 27x plus 27. And so we get this right here. Okay, so now let's use it with an exponent of 5. So when my exponent is 5, we're going to use the row that has a 5 as the second number. So the coefficients we're going to use are 1, 5, 10, 10, 5, 1. We're going to take the first term and take it to the 5th power. So that would be x to the 5th. And then we descend from there. 4, 3, 2, 1, and then 9. From here, what we do is now we're going to take the second term, which is a positive 3, and we're going to work in the opposite order. So we're going to take 3 to the 5th, 3 to the 4th, 3 to the 3rd, 3 to the 2nd, 3 to the 1st, and then no 3. So now we multiply. 1 times x to the 5th is x to the 5th. 5 times x to the 4th times 3. 5 times 3 is 15. X to the 4th. Then we have 10 times x to the 3rd times 3 squared. 3 squared is 9. 9 times 10 is 90. X to the 3rd. Then we have 10 times x squared times 3 to the 3rd. 3 to the 3rd is 3 times 3, which is 9, times 3, which is 27. 27 times 10 is 270. Then you have x to the 2nd power. From here, we have 5 times 3 to the 4th. 5 times 3 to the 4th. So 3 to the 4th is 3 times 3, which is 9, times 3, which is 27, times 3, which is 81. Then we're going to take 81 times 5. 81 times 5 is 405. And then it would be x to the 1st power, which you don't have to write the exponent. And then we're going to do 3 to the third power. Well, we know 3 to the third power is 81. So we're going to take 81 times 3. 81 times 3 is 243. So you could do 81 times 3. 3 times 1 is 3. 3 times 8 is 24. Okay, you could have also done that with the 5 times 81. So now that we have that, our final answer is x to the 5th plus 15x to the 4th plus 90x to the 3rd plus 270x to the 2nd plus 405x plus 243. And that would be what x plus 3 to the 5th power would equal. Okay, now this can be very tedious as we go through it. So there is going to be a separate video where I do show you how to use the calculator to get some of these values from the triangle. Because if I gave you, let's say, x plus 3 to the 10th power, you don't want to have to expand this triangle out even more than we already have. So we're not going to actually expand out to the 10th power, but you may be asked, if the exponent is 10, what is the third or fourth coefficient using Pascal's triangle? And we need to be able to do that. So let's look back at our notes to see. So it says, what if we wanted to expand the expression x plus 3 to the 7th power? As you can imagine, this would be very tedious and time-consuming using the method from above. So fortunately, there's a great mathematical property and tool to make this process much easier, and that is the binomial theorem. So this binomial theorem looks scarier than what it is, but don't worry about that, okay? So at first glance, the binomial theorem may look intimidating and complicated, but in reality, it is easy to use and understand if you remember a few details. So when expanding the binomial expression, a begins with the degree of n, and the b term begins with the degree of 0. So that was why I started at the bottom and I worked my way up for that second term. Okay. As we expand the binomial expression, the degree of a decreases by 1, while the degree of b increases by 1 until b reaches the degree of n. So if I look back to the ones that we've done, okay, in this case, the a is x, the b is 3. So notice that a, these exponents are decreasing until there's none, while these are increasing until it gets to a degree of 5. That's what that's talking about. Okay, so Pascal's triangle, we can use Pascal's triangle to find the values of the coefficients n over 0, n over 1, n over 2 in our expansion. And so this notation is going to be something that you see whenever I make the calculator video. So here's Pascal's triangle. I've already talked about how we get each term. Again, you add the windows, or you add the two numbers to get the window. So 1 plus 1 is 2. 2 plus 1, or 1 plus 2 is 3. 2 plus 1 is 3. It always starts with a 1, ends with a 1. So this very first row is row 0, because if you take a plus b to the 0 power, anything to the 0 power is 1. If you take a plus b to the first power, well, then that's just 1a plus 1b. And that's why that row is 1, 1. Then we've already done a row 2 and a row 3, okay? And it keeps going. Row 4, row 5, row 6, row 7. The row number comes from the second number in each line, okay? Now, it says, note, the value of n over r corresponds with the rth term in the element in the nth row of Pascal's triangle. We'll get more into that. The first number in each row is the 0 element of the row. So if we wanted to talk about a specific term, let's talk about row 6 right here. If we're talking about row 6, okay, row 6 would be n. So if we're talking about, let's do row 6, and let's talk about the third element. We would talk about this row right here, which is row 6. Okay, so row 6 would represent n being 6. If we want the third element, then we would have r be 3. Well, r being 3 would have it looking like 6, 3 like this in parentheses, and we're going to see that notation whenever we use the calculator. And so what that's saying is we want the third element. Well, this important part down here says the first number in each row is the 0 element. So if I want the third element, this is 0, this is 1, this is 2, this is 3. So I would get 20 as my answer for this. So that's something that has to deal with probability. So that, again, something that has to do with probability. I will show you how you can use the calculator to find this, but again, we'll come back to that in the video over the calculator. Okay, so we have Pascal's triangle again. In the Pascal's triangle above, the 5th row is circled. So this is explaining just a different row of what I was just talking about. Okay, in the 5th row, the first number 10 has been circled, or the first number, so the first 10. The circled 10 is the second element in row 5. So that would be 5 over 2 equals 10. So this is row 5. Remember, this is 0, 1, 2. So that is my second element. Okay. The notation represents a combination where n over r equals this notation right here. So this is n factorial divided by r factorial times n minus r factorial. And so something about factorials, we're not going to get much into them, but if we had 5 factorial, all that means is you're taking 5 times 4 times 3 times 2 times 1, and you would multiply that out. If you had 6 factorial, that would be 6 times 5 times 4 times 3 times 2 times 1, so on and so forth. Okay, now you will not need to know this formula for the AP pre-calculus exam. Okay, you do not need to know it. But if you know this part right here, you can use your calculator to help you find some of these numbers from Pascal's triangle. So we're not going to stress about that part right now. That's going to be in part 2 where I talk about that formula. So in example 10, we're going to use Pascal's triangle to expand x plus 2 to the 5th power. So we did do this one, not this particular one, but we did x plus 3. So I want you to pause the video and try this one on your own. See how you do, see where you get stuck, see where you have questions. So with this, we're using the 5th row where the coefficients are 1, 5, 10, 10, 5, 1. We're going to take the first term and we're going to have that one with the exponents going down, starting with an exponent of 5. X to the 5th, x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, no x. Then we're going to take the second term, which is a positive 2, and do the opposite. I personally like to start at the bottom and go 5, 4, 3, 2, 1, none. But you can also start with none, 1, 2, 3, 4, and 5. Okay, so from here, we just need to multiply this stuff out. So 1 times x to the 5th is just x to the 5th. 5 times x to the 4th times 2 is 5 times 2 is 10, x to the 4th. So really you just need to focus on multiplying the numbers out. Okay, the next one, we're going to take 10 times x cubed times x squared. Well, x to the second power is 4 times 10 is 40, and then it's an x cubed. We have 10 times x squared times 2 to the third. 2 to the third power is 8. 2 times 2 is 4, times 2 is 8, times 10, that is 80x to the second power. We have 5 times 2 to the 4th. So 5 times 2 to the 4th. 2 to the 4th is 2 times 2, which is 4, times 2, which is 8, times 2, which is 16. So we're going to take 16 times 5. 16 times 5 is 80x. And then 1 times 2 to the 5th. Well, 2 times 2 to the 4th power was 16. 16 times 2 is 32. So this expands into x to the 5th plus 10 x to the 4th plus 40 x to the 3rd plus 80 x to the 2nd plus 80 x plus 32. So we get that. Okay. Now, everything we've done so far, there has not been a number in front of the x, so it's been pretty basic. Now, we're going to add in a number in front of the x and a minus sign. So, use Pascal's triangle to expand 2x minus 1 to the 4th power. So, if we're looking at Pascal's triangle, my exponent is 4, so we want to use the row that has a 4 as the second number. So we're going to have 1, 4, 6, 4, 1. So we take the first term, which is now a 2x, and we're going to start with an exponent of 4, 2x to the 4th power, 2x to the 3rd power, 2x to the 2nd power, 2x to the 1st power, and then no 2x at all. Then we have the second term, which is now a negative 1. The fact that it's negative is important. So we have negative 1 to the 4th power, negative 1 to the 3rd power, negative 1 to the 2nd power, negative 1 to the 1st power, and then no negative 1. So we simplify this. We multiply. 2x to the 4th power is 2x times 2x, which is 4x squared, times 2x, which is 8x to the 3rd power, times 2x again, which is 16x to the 4th power. So again, when you have the entire number in the parentheses, that means that you have 2x times 2x times 2x times 2x. 2x times 2x is 4x squared. 2x times 2x is 4x squared. 4x squared times 4x squared is 16x to the 4th power. That's how we got that. So that's going to be for all of these that have 2x in parentheses. So now we have 2x to the 3rd power. That would be 2x times 2x times 2x. That would be 8x to the third power. Now, 8x to the third power is being multiplied by 4. 8 times 4 is 32x to the third power. And then we're multiplying it by -1. So we get a negative 32x to the third power. The next one, we have 2x to the second power. That's 2x times 2x, which is 4x squared. 4x squared times 6 is 24x squared times -1 squared. -1 squared is a +1. +1 times 24x squared is a positive 24x squared. Then we have 4 times 2x times -1 cubed. -1 cubed is -1. 4 times 2 is 8 times -1 is a -8, and the variable is x. And last but not least, -1 to the fourth power. -1 to the fourth power is a +1. So for this to be fully expanded, we have 2x minus 1 to the fourth power equal to 16x to the fourth minus 32x to the third plus 24x squared minus 8x plus 1. And that would be fully expanded. Okay. Now, on example 12, what is the coefficient of the term containing x to the fourth when the expression x plus 5 is expanded? So you do not have to fully expand everything. All you have to do is know when you get to the x to the fourth term. So if we are using an exponent of 6, that means we need the row that contains the 6. So we're going to use 1, 6, 15, 20, 15, 6, and 1. So I'm going to list those out. And again, once you realize what term you're looking for, you can stop. So I'm just going to list a couple of them out. 1, 6, 15. And then I'm going to have my first term, which is x, and I'm going to start with the 6. So x to the 6th, x to the 5th, and x to the 4th. So this is the term that we're focusing on. Okay, so we're only focusing on that x to the 4th term because that's what it asked for. So if we're thinking about the second term, a +5, it would start with no 5, and then 5 to the first, and then 5 to the second. And so for this one, you will need to use your calculator to help you out. So you should have one available to you. And so in your calculator, you can type in 15 times 5 to the second. 15 times 5 to the second, or 15 times 25. You will not type in the x value or x to the fourth. You're just doing 15 times 5 squared. 15 times 5 squared is 375 x to the fourth. Now, you have to know what it's asking for again. So it says, what is the coefficient? The coefficient is just the number. So the coefficient is 375. It does not want the x term. If you list the x term and you list the wrong x term, you could potentially lose credit. So only answer what it wants. Okay. Now, example number 13 will be covered with the calculator. Okay, number 13 will be covered with the calculator. And then now let's take a look at the last two multiple choice. So again, 13, there will be a separate video showing you how to use the calculator. In example 14, actually, if you want to pause the video and try example 14 and example 15, do so. That way you can see how you do and see where you're struggling still. So, what is the leading coefficient of the fourth term when x minus 2 to the sixth power is expanded? So, we want to the sixth term, or sorry, the sixth exponent, and we want the fourth term. So, we have 1, 6, 15, and 20. That would be the fourth term. Then we have, and you have to keep that part separate from when I was talking about it earlier with the calculator. Okay. From here, we're going to take, let's see, x, and it's going to go x to the sixth, x to the fifth, x to the fourth, x to the third. Then we're going to take negative 2, and we're going to have negative 2. Actually, that one is not going to have a negative 2. Negative 2 to the first, negative 2 to the third, to the second, and negative 2 to the third. So what we should know is that on this particular problem, I'm taking negative 2 or a negative number to the third power, which means my answer should be negative. So then I'm going to multiply. So that would be 20 times negative 8. 20 times negative 8 is a negative 160. So this should be a negative 160. Okay. Next one, what is the second term when 2a plus b to the fourth power is expanded? So when my exponent is a 4, we're going to use 1, 4, 6, 4, 1. So we're going to do, and all we want is the second term. So we have our first thing. Now our first thing has two parts, 2a. So we have 2a to the fourth, 2a to the third. Then we have our second term, which is a negative 4, or sorry, a negative b. So that would be no negative b and then negative b to the first power. So once again, this will turn out to be a negative answer. If we look at all our answer choices, they are negative. So we have 4 times 2a to the third times negative b to the first. That would be 4 times 2a to the third is 8a to the third times a negative b. 4 times 8 is 32. 32 times negative 1 is a negative 32. Then you have a to the third b. So when we look at our answer choices, that would be answer choice A. And that's all you would need for that. So if you have any questions, please make sure you write them down so you can ask in class.